find where these are. So yesterday we talked about the measurement relationships between angles. We talked about some of them being congruent, and then some of them being supplementary. So, of the angles we learned yesterday, which ones were congruent? We have alternate exterior. What else was congruent? Alternate interior. And then vertical. And then also corresponding. Please make sure you have a pass. You good? From the office? You bring it to your desk. All right, supplementary. What relationships were supplementary? So consecutive interior. What's the second one we talked about?
Linear pair.
And a linear pair. Linear pair. So you need to define the relationship and then figure out if that means they're congruent or supplementary. So what relationship does the angle I'm given and 21x plus 6 have? Alternate exterior. Go ahead and write that in. They are alternate exterior. What does that mean about their measurements? They're congruent. So what is the measure of this box up here? 90. So then what is the measure of the angle down here? 90. So you're going to say 21x plus 6 equals 90. Okay, because they equal each other. So then from here we just do some algebra. What would I move next? The 6. So I'm going to subtract 6. 21x equals 84. Divide by 21 and x equals 4. Good. So that's the first. The second, what relationship do these two angles have? They're corresponding. So I'm going to write that at the top. What do we know about the measurement of corresponding angles? They are congruent. So that means we have 75 degrees, and that means 11x minus 2 equals 75. All right, so then what would I do next? Add 2. So 11x equals 77. So then x equals 7. Good. Go ahead and flip. So we have 60 degrees and 8x minus 4. What relationship do these two angles have?
Alternate interior.
Good, alternate interior. What do we know about the measures of alternate interior angles? They're congruent. So then what will 8x minus 4 equal? 60. You're good. So 8x minus 4 equals 60. So from here I solve. My next step is to add 4. So 8x equals 64. So this means x equals 8. The next one, what relationship do these two have? Yep, they're alternate interior again, which means they are still congruent. So I want you to pause. So everyone put down your pencils. So we're saying x plus 139 equals 132. So we are saying a number plus 139 equals 132. What is the only way to add a number to 139 to make it go down to 132? Well, it'll be negative. So can you have a negative x? Yes, you can. Can you have a negative angle? No. So the x is okay to be negative because when you plug it in, it would make it equal 132. Okay? So we can continue. What is our only step? Subtract 139. So x equals negative 7. So again, it can be negative because when I plug that in, minus 7 plus 139 is 132. All right, we got one more to do together. We've already done this one, right, on the left? So we'll do the right problem. What relationship do these two angles have? Corresponding. Make sure you pick up the notes. So corresponding. What do we know about the measures of corresponding angles? They're congruent. So if their measures are the same, what can I do with these two algebraic expressions? Set them equal, because they do equal. So 23x minus 5 equals 21x plus 5. All right, so what's my smaller x to move? 21. So I'm going to subtract it. So 2x minus 5 equals 5. My next step is to add 5. So 2x equals 10. So then x finally equals 5. Good. You're going to go ahead and take out your homework. All right, so we're going to talk about proofs with parallel lines. So basically today, we are going to prove that lines are parallel. That's our goal. Prove that lines are parallel. Okay, so we're going to start at the top of our notes. The first word we talk about is parallel in and of itself. So what are parallel lines? We talked about it yesterday. They are lines that are... They intersect. What was the first part, though? Are they on the same plane? Yes, they are. So they're coplanar and do not intersect. So coplanar and do not intersect. That's your first blank. Parallel lines are coplanar and do not intersect. Parallel lines are coplanar and then do not intersect. So how do I know the little lines, sorry. The lines on my page are parallel? What tells me it? The little triangles, okay, they tell me that they're parallel. So basically in this section, they won't have the triangles. We're going to have properties that prove that they're parallel. Okay, triangles won't be there. We're going to be proving them with properties. You actually already kind of know them. Okay, we'll talk about it. In this section also, they're naming L. What is this? What does this symbol mean? Parallel. So it says line L is parallel to line N. Is this how we name lines? No. So what is it missing? The word line. So when you see it, this is not the habit to get in. You need to write line L is parallel to line N, because that's the accurate way to sign it. Okay? So there's that. And then we talked about transversal. What is a transversal? Good. A line that intersects two or more lines. So go ahead and fill that in too. A line that intersects two or more lines. So a line that intersects two or more lines at different points. Okay, so still your transversal is a line that intersects two or more lines. What you're going to highlight, the very next sentence. It says properties that prove two lines are parallel. It's got a question mark? That's what you highlight. This entire section is over this next box. My last class, don't know what they were doing. Okay, they decided some of them weren't going to fill in the box. This is literally what the section's about. So, we're going to talk about four properties. So yesterday, we learned that if you had two parallel lines, we learned alternate exterior angles were what? What were their measures? They were congruent. We then learned that if you had two parallel lines, alternate interior angles were congruent. We learned that if you had two parallel lines, vertical angles were congruent. We learned that if you had two parallel lines, corresponding angles were congruent. And then we learned if you had two parallel lines, consecutive angles or consecutive interior angles were supplementary. So here we're going to learn the opposite. Okay? The opposite's going to be happening. So instead of being told you have two parallel lines, so these are congruent or supplementary, you're going to be told if, it'll pop up, you have corresponding angles, okay? So don't write anything down yet. If you have two lines that are cut by a transversal, so that the corresponding angles are congruent, that is enough to prove the lines are parallel. So in your first blank, on the left side of the column, you can write in the entire box, you're going to write corresponding angles. That's the first property that proves that two lines are parallel. Corresponding angles. Corresponding angles. So what do corresponding angles need to be? I just said it. They need to be congruent. That's the blank on the right side. So corresponding angles need to be congruent. Again, that is the blank in the right column, because you have the exact sentence I have on the screen. Okay, is this new information? No. Again, instead of being told you have two parallel lines, that makes corresponding angles congruent. Now you're going to be saying, if you have corresponding angles that are congruent, that's enough to prove you have parallel lines. Because are there triangles in this picture?
Yes.
In this picture? On mine? No. There's nothing proving that J and K are parallel. So we're using properties to prove that they're parallel. Okay, so if you had angle 1 congruent to angle 5, then that's enough to prove J and K are parallel. Why did they pick 1 and 5? Because they're corresponding. They're both in the top left. What about 2? What would 2 be corresponding with? 2. So if they had 2 and 6. So if 2 and 6 were congruent, then that's enough to prove that the lines are parallel. If 3 and 7 were congruent, or 4 and 8 were congruent, that is enough to prove the lines are parallel. Okay, so this is the first property. The second property are alternate interior angles. Let's go ahead and write that in. Alternate interior angles. Alternate interior angles. So it says the two lines are cut by transversal, so that the alternate interior angles are blank. What's my blank? Congruent. So if your alternate interior angles are congruent, that is also enough to prove that you have parallel lines. Okay, so in my picture, that would be 3 would be congruent to 6, and then 4 would be congruent to 5. So if you had either of these pieces of information, you would say these lines are parallel, J and K are parallel, because the alternate interior angles are congruent. Yes, sir? This is the second box. Oh, maybe it's flipped. It's fine. Because the next one's alternate exterior. So however you write it, they're the same property. So if two lines are cut by a transversal, so that the alternate exterior angles are congruent, then the lines are parallel. So this is the next property. So alternate exterior. So what do alternate exterior angles need to be in order for my lines to be parallel? They got to be congruent. Is that new information? No. No, it is not. It's okay. The last one, so if 1 and 8 or 2 and 7 were congruent, that's enough to prove the lines are parallel. Consecutive interior. So the last one deals with consecutive interior. Okay. So if two lines are cut by a transversal, making the consecutive interior angles supplementary, then that is enough to prove the lines are parallel. Okay, so supplementary. What does supplementary mean to me? Two angles that add to 180. So that means angle 3 and angle, it's the same color, 3 and 5. So if the measure of angle 3 plus the measure of angle 5 equals 180, or if you had the measure of angle 6 plus the measure of angle 4 equals 180. Okay, so here's what we're going to do with this. Our first examples. Decide whether there is enough information to prove that line P is parallel to line Q. So we're looking for one of these 4 properties. That's all we're looking for. If you have one of these 4 properties, they prove that lines are parallel. If you don't have one of these 4 properties, you don't have enough to prove the lines are parallel. So we're going to start with, this is number 3. What do these arcs mean to us?
90.
They don't mean 90, they mean congruent. So we have 2 angles that are marked congruent. What relationship do these 2 angles have? They're corresponding. Are congruent corresponding angles a part of my theorems that prove that lines are parallel? Yes. So you would say yes, because it's asking if there's enough information. And then you need to explain what theorem. Nope. So because corresponding angles, what do we know about them? Are congruent. You can use abbreviations like angles and congruent. Then that's literally the answer. So yes, because corresponding angles are congruent. The second one, we have two angles marked congruent. Are they corresponding? No. They need to be in the same spot. The first one's in the top right, the second one's in the top left, so they're not corresponding. Are they both on the interior? No. Are they both on the exterior? No. So they can't be any of these remaining three. Do they have any relationship whatsoever? No. So is there enough information? So you would say not enough information. You could say not enough info. And then we flip. Find the value of x that makes line M parallel to line N. So we need one of these relationships to be true. Is there a relationship between the two angles they gave us? Yes. What relationship is that? Corresponding. What do corresponding angles have to be? Congruent. So what does 3x plus 5 have to equal? 65. So we're going to say 3x plus 5 equals 65. So my next step would be subtract 5. 3x equals 60. Divide by 3 and x equals 20. That's it. Question about this one. So was this different than what we were doing yesterday? Nah. Yes, ma'am.
Would we have to write out first? Like, if it's not so many?
No. It's just asking find the value of x. The other ones were asking what, like, if so, state the theorem you used. So that's why we had to state which one we used. All right, this one. Determining whether lines are parallel. So we did one similar to this yesterday. You're going to put a star. And I'm going to remind you, the easiest way to answer this question is to define all relationships in the diagram. So define all of the relationships in the diagram. So it says in the diagram, R is parallel to S. What in the diagram already told me that? Yeah, the little arrows. Okay, that already told me that. And angle 1 is congruent to angle 3. There's nothing in the diagram that told me that. Okay, they had to give me that information. We're trying to prove that P is parallel to Q. So the number one way to do this is define all the relationships. So here's what we're going to do. We're going to start with what they gave us. Angle 1 is congruent to angle 3. That's important for me. Angle 1 is congruent to angle 3. There is no formal relationship between angle 1 and angle 3. Correct? They're not on the same transversal. 3 is on line R. Everyone sees this? Whereas 1 is on line S. So they're not on the same transversal. They have no relationship. They had to give us the information that angle 1 is congruent to angle 3. We wouldn't have found that on our own. From here, we list all of the remaining relationships. So pick two other angles to name their relationship.
2 and 3.
Sure. 2 and 3. So what relationship do angle 2 and angle 3 have? So they're alternate interior, which makes them congruent. So angle 2 is congruent to angle 3. That's why I left that blank. So angle 2 is congruent to angle 3 because they are alternate interior. You can technically say they are. What other pair of relationship have we not mentioned yet? 2 and 1. I'll say 1 and 2. So what is the relationship between 1 and 2? They're what? They're corresponding. What do we know about corresponding angles? They're congruent. So you're going to say angle 1 is congruent to angle 2. Okay, that's why I left that blank. So all you're doing is telling me what's congruent or supplementary, and then telling me what relationship they had together. Here's why. How many degrees, just take a guess, how many degrees does angle 3 look like it is? Definitely doesn't look like, oh sure, 80 is fine. I'd say like 70, but that's me. So we said at the beginning, so let's say it was 80 degrees. We're just making it up just to prove the point. At the beginning, they told us angle 1 and angle 3 were 80 degrees. Yes? Xander, it's really hard to understand geometry without looking at it. So we know that angle 1 and angle 3 are congruent. Yes? So they told us that. That's not me making up information. That's me reading the directions. We then said 3 and 2 were alternate interior. Yes? So then what's the measure of angle 2? 80. We then said 1 and 2 were corresponding. So they also have to be congruent. Is that true? Yes. So because all of these relationships are true, this is enough to prove that P is parallel to Q. Okay? Because all of the relationships fit in perfectly. That's all you have to do. Okay? Questions on a problem like this?